Welcome to video 7.6. Today we're going to be solving radical equations. So our objective for today is to solve equations that contain radicals or rational exponents. When we're solving radical equations, the key step is to raise each side of the equation to the same power. So for example, if you had an equation such as a equals b, then those equations are still equal if they are raised to the same power of n. So for example a, we have the equation 5 minus the fourth root of x equals 0. So the first thing we want to do is to get the x isolated on one side. So we isolate the fourth root of x. Now we want to isolate x. So I would raise both sides to 4. And when you raise both sides to the fourth, you're going to end up with x by itself on this side, but then 5 to the fourth will give you 625. Okay, in example B, we want to isolate the cube root of x. So we would subtract 6 from both sides. We have the cube root of x equals 6. Now, once again, I want to raise both sides to the third. And when we raise both sides to the third, we get x by itself, and 6 to the third is 216. So now we're going to solve radical equations that are written in exponent notation. It's still the same idea. What we want to do is we want to get that x by itself. So I have 3x to the 4 over 3 equals 243. So the first thing I want to do is I want to divide both sides by 3. Once I do that, I get x to the 4 thirds equals 81. Now what I want to do is I want to multiply this exponent by something that's going to eliminate it. So I know that if I multiply 3/4 by 4 thirds, these are going to cancel out. If I do it to one side, I have to do it to both sides. So I'm raising both sides to the 3/4. When I do that, the 4 times 3 is going to equal 12. 3 times 4 is going to equal 12, so I'm going to end up with just x equals 81 to 3/4. Which we know we can rewrite as 81 to the 1/4 cubed. I know 81 to the 1/4 is 3, and 3 cubed is 27. 27 is your final answer. Okay, let's work on this example. Same idea, we want to get x by itself, so we divide both sides by 2. We end up with x to the 1/4 equals 4. Now we want to raise both sides by 4 to get rid of the 1/4. So 4 times 1/4 will leave us with x, and 4 raised to the 4 is 256. On these examples, we're going to have a variable and a constant under the radical symbol. So we have to kind of keep those intact as we try to isolate x. So we have this minus 4 here that we want to get rid of on the left side. So we add 4 to both sides. So we have the square root of 2x plus 8 equals 10. Now I want to get rid of this radical symbol, so I'm squaring both sides. Remember, the square root symbol basically just means the second root taken of it. So if we square both sides, we end up with 2x plus 8 equals 100. Then we subtract 8 from both sides, we get 2x equals 92. We divide both sides by 2, and we get x equals 46. Okay, in example B, we have the fifth root of 2x plus 1 plus 5 equals 9. So I want to isolate the radical with the variable in it. So I subtract 5 from both sides. Then I want to raise both sides to the fifth, because I want to get rid of that fifth root. When I do that, I end up with 2x plus 1 equals 1024. So I want to subtract 1 from both sides. and divide both sides by 2. So I get x equals 511.5. Now, when we have two radicals, what we want to do is we want to get them on different sides of the equal sign. So I'm going to end up with 6 times the square root of x, and I have this minus square root of x minus 1. But what I want to do is I want to get this on the other side of the radical symbol. Okay? Now once we have it set up like this, we can isolate x. I know that I want to get the x's away from the radical, so I want to raise both sides to the same power. I want to square both sides. Now, if these were being taken the cube root of x on both sides, I would raise to the third. But since it's just a square root, I square both sides. So now when I do this, I end up with 36 times x equals x minus 1. Then I subtract x from both sides. I end up with 35x equals negative 1. Divide both sides by 35. And x equals negative 1 over 35. Okay, so let's look at something that we call extraneous solutions. So if I have the equation square root of x equals negative 1 and I want to solve for that, and we use the tactics that we've learned in this section, the first thing you would think is to square both sides. So we have this equation, square root of x equals negative 1. If I square both sides, I end up with x equals 1. Now, what happens when you plug your answer into the original equation? So the square root of x equals negative 1 is my original equation. This is what I got for an answer. If I plug that in for x, I know that the square root of 1 is 1, but 1 does not equal negative 1. So this is what we call an extraneous solution. So raising both sides of an equation to a power may cause extraneous solutions, so you always want to check your answers. So let's practice that idea with example A. So I have x plus 2 equals the square root of 2x plus 28. The first thing I'm going to want to do is I'm going to want to take both sides and square them. Now be careful here on the left side to not do x squared plus 4. I know a lot of people tend to make that mistake, but that's not the right way to do that. The correct way to write this is x plus 2 times x plus 2 on the left side, and then on the right side, since this already has a radical symbol under it and we're squaring it, it's going to become 2x plus 28. Then we're going to simplify the left side to be x squared plus 4x plus 4 equals 2x plus 28. We want to bring the 2x over, so we subtract 2x from both sides. We end up with x squared plus 2x. Then I'm going to subtract 28 from both sides, so I'm going to end up with negative 24 equals 0. Now remember, I'm solving for x, so at this point I can factor to solve for x. So I make my two binomials. I know I need to have a factors of 24 that if you combine them gave me 2. So I know I have to use 6 and 4. Now since this 2x is positive, I know the bigger number needs to be positive, small number needs to be negative. And both the variables are going to be x. So now to solve for x, I have to set up two equations. I have to do x plus 6 equals 0 and x minus 4 equals 0. So my solutions are negative 6 and 4. But now we need to plug these equations back into A and see which one works, or if they both work, or if none of them work. So here's our original equation. Now let's plug in negative 6 and see what happens. So if I plug in negative 6 in for x, I have negative 6 plus 2 equals the square root of 2 times negative 6 plus 28. On my left side, I'm going to end up with negative 4. And on my right side, under the radical, I'm going to have negative 12 plus 28. So I have negative 4 equals the square root of 16. We know the square root of 16 is 4, but negative 4 does not equal 4. So negative 6 is an extraneous solution. Now, let's try out x equals 4. So I'm going to plug this back into this equation. And when I do that, I end up with 4 plus 2 equals the square root of 4 times 2 is 8 plus 28. Now on the left side I simplify 4 and 2 to get 6, and on the right side I end up with 36. And we know that the square root of 36 is 6, so this checks out. I'm happy. But I'm not happy with this one, because that one did not work. Okay? So what I want you to do now is to practice doing equation x minus 3 equals the square root of 4x, and we will go over that together. Once again, I want to thank you for tuning into this video, and I'll catch you on the next one. Thank you.